Welcome to Kojo's Pre-Algebra, and today we're going to be talking about word problems. That is one of the most difficult concepts for students to do, is the actual application of equations to word problems. Alright, so here we go. You should be familiar with all of this. Labels, the verbal model, the algebraic equation, and the verbal model and the algebraic equation should match. Remember, the verbal model is not writing out the numbers in words. It's writing out what the numbers represent in words in the form of an equation. Then, after you've figured out your verbal model, then you take the labels, you plug it into the verbal model, and then you take the value, the numbers that represent those labels, those words, and you plug it into the algebraic equation written the exact same way as the verbal model, and these should match in the same order. Makes life more easy. The other thing that you need to remember is that you need to check to see if the answer makes sense. You're not checking your math to see if you did it correctly. You're checking to see if your answer makes sense, because if you just check the math and you set the equation up incorrectly, the math is going to be correct. And you're going to check and say, oh, it's right. When it doesn't, it's not right because it doesn't make sense. And if you catch and say, does this make sense? You go back to the answer, or to the question, excuse me. You go back to the question, you say, does this make sense? And if it doesn't, then you go back and check your equation, not your math, to see if you added and subtracted properly. But if you have it set up properly, where is the mistake? Okay, so we're going to be focusing during this time period before Thanksgiving, we're going to be focusing on three types of word problems. We're going to be focusing on numbers, which we've already been introduced to, where you say, okay, find 3 consecutive even integers, or 3 consecutive odd integers, or 3 consecutive integers. You know that, and you should remember about labels and algebraic equations and verbal models. And if you don't, we're going to go over those. We're going to be working them on a great deal this next week or two. So the other one we're going to be doing is money problems, and there's something very specific about that you need to remember, and geometry. The two that we're going to focus on this video, we're going to do a geometry problem first, because those are very difficult, because you have to process, you have to think about them, and the money problem. So what I want you to do is I want you to pause the video, and I want you to write this problem down. Find the area of the swimming pool if the total swimming area, including a 3-foot sidewalk all the way around, so that includes the 3-foot sidewalk, is 2,400 square feet. The length of that swimming area is 60 feet, and the width is 3x minus 5. So stop the video or pause the video and copy this down, and then come back. Okay, let's get busy with this, because we're going to work this one together. I'm going to suggest to you that every time you have the opportunity that you draw a picture so that you can visualize it. It's really important to draw a picture whenever you think that it might help you. So I'm going to draw a picture of a swimming pool, and you guys know my drawing. Now, what did it say? It said the whole length was 60 feet, and it said that it was 3x minus 5 was the width, but they gave us one more piece of information that was critical. Do you remember what it was? Yeah, the 3-foot sidewalk that goes all the way around the swimming pool. So here we go. Doesn't have to be perfect. And this is all 3 feet. Now you got to pay attention, because this is 3 feet. And I'm going to label that. You're starting to see how that's going to impact it? All right. Then it said, so my labels are that I have total area is 2,400 square feet. You realize I don't have an x? I can't really identify what x is. X is just a number. So you can put x is a number. It has nothing to do with the width or the length, or it doesn't stand for anything, but it's a number. We have to identify what x is. I'm not going to use it in the equation because it's going to be used with the width. So then we have 3x minus 5 equals the width, and 60 is the length. Okay, the verbal model, we have to write area equals length times width. That can be your verbal model, because this is length times width equals area. You have to identify the equation. That would suffice for the verbal model. So now I'm going to say 2,400 equals the length, which is 60, times 3x minus 5. It's the distributive property because 3x minus 5 is a binomial. Okay, so let's do the problem and see if you can see what happens. We have 180x minus 300. I'm going to add 300 to both sides. I distributed 60 times the quantity of 3x minus 5. I'm going to add 300 to both sides. I get 2700 equals 180x. When I divide both sides by 180, I get, I'm going to cheat because I don't have it. I get x equals 15. Remember what I said? That's not feet. That's the number. That's a number. Okay, what do we have here? We have an x. We've solved for the value of x. Now, recognize we're not going to just go in and plug it in for here and get 3 times 15 is 45, minus 5 is 40, and 40 times 60, and say that's 2,400 square feet. Well, that's what the total area was. So that would be 40 times 60. You got that? So that doesn't help us. So think, what are we going to do to find the area of the swimming pool? Where does the key? The key lies that there's 3 feet of sidewalk around the entire pool. So if there's 3 feet on this side and 3 feet on this side, that sidewalk, what is the length of the swimming pool? I hope you got it. 60 minus 6, which is 54 feet, which is the length of pool. Then do you know what to do to find the width of the pool, which is here? Well, we went and said 3 times 15 is 45 minus 5, which is 40, but that is the entire total area's width. So we're going to say 40 minus 6, not just 40 minus 3, because it's on each side. See that? So we're dealing with 34. 34 feet is the width of the pool. So what are we going to do? We're going to multiply. We're going to go area equals length times width. We're going to say area equals 54 times 34. And area equals, if you multiply that out, it comes out to 1,836 square feet. Oh, that's ugly. Multi-steps. That's like worth 10 points on my test. Because look, you have your labels, you have your verbal model, you have to first find out what the x is so that you can solve for the total area of just the pool. Okay, that is going to be on the test for sure. And it might be just a little tweaked to be a little bit differently. It might be talking about a computer screen. It might be talking about a television screen. It might be talking about a garden with a row around it, that you've got like a brick walkway around it or something like that. Okay, so now let's go to the next one. Money. All right, with money type of problems, word problems, you have to make sure that the units are the same. Either you're talking about a total value of coins and they give you a value, or you're talking about a total number of coins and they give you the total number of coins. Whichever the one they have, you can't have both in the same. You can't have partial value of coins equaling total number of coins. The units all have to be the same. That's where students get mixed up and they make lots of mistakes. They don't keep everything consistent. Like either you're talking about total value of coins or you're talking about total number of coins. So here's an example. Pause the video, write this down, then try to set up labels and an equation. I'm going to read it for you because it might be hard to read. A collection of coins has a value of 64 cents. There are 2 more nickels than dimes and 3 times as many pennies as dimes. How many of each kind of coin are there? They want to know the total number of coins. So you should be able to set up, their labels are going to have like, what's X going to be? The number of, I'll give you a hint. The number of what? What's everything being compared to? Nickels is being compared to dimes, and pennies are being compared to dimes. So X is the number of dimes. So pause the video, write this problem down, and then set up the labels, set up the verbal model, and set up the equation. But don't write down, don't try to solve it, because I don't want you to waste your time if you set it down and set it up incorrectly. So pause the video and then come back. Welcome back. So let's see how you did. All right, let's see. Let's see, I hope you did well. I hope you caught my little thing. Did you set up this, that x equals the number of dimes? I didn't put number, but you'd have to write number of dimes. X plus 2 is the number of nickels, because it's 2 more. And you had 3 times as many pennies, so 3x is the number of pennies. Did you have number of dimes plus the number of nickels plus the number of pennies equals the total value, which would be x plus the quantity of x plus 2 plus 3x equals 64? This is wrong, because this is a value, and these represent the number of the coins. You cannot do that. It will not work. You can't get the answer, because you didn't get a total number of coins given to you. If they didn't give you a value and they said the total number of coins in your pocket was this, 64, then you could have done it this way. But they gave you a total value. So you can't do it this way, because this is the number of dimes, the number of nickels, and the number of pennies. Okay? So this is how you should have done it. Maybe you did, and if you did, I'm happy. The first thing you do is, because they didn't give you, they didn't give you a value, they did give you the number of coins, everything based on the dimes. So your labels start out with a total value of 64 cents. You have 3 dimes. Wait, no, that's the answer. Don't look at the green. You had x equals the number of dimes, and then you had to put the value of the coins, because they gave you a total value of 64 cents. So x represents the number of dimes, and 0.10x represents the value of the coins. Very important. X plus 2, the quantity of x plus 2, the quantity of x plus 2, and you might even want to write that in there, because you have to distribute when you're talking about the value of the coins. 5 cents times the quantity of x plus 2. And then the total number of pennies was 3 times the number of dimes, so it's 3x. That's the number of pennies. But the value of the pennies is 1 cent times 3x. Okay, my verbal model is the value of dimes plus the value of nickels plus the value of pennies equals the total value. See, now I can't have number of dimes, number equal a value. I have to have value equals value, or number equals number, total number. That's the most important thing you can learn from this video. So I'm going to set it up where I don't use this by itself. I use it over here where I've plugged in the value of the coins. So I get 0.10x plus 0.05 times the quantity of x plus 5 plus 0.01 times 3x equals 0.64. I multiply by 100 to get rid of all the decimals. I don't distribute first. I get rid of the decimals. So this becomes 10x. But here, I don't distribute. Remember, this is a factor of the quantity of x plus 5, so I don't distribute the 100 inside the parentheses, because this is multiplication. As long as I do it to the 0.05, I'm okay. So I get 5 times the quantity of x plus 2. That's plus 2. I made a mistake when I was writing this down. It's plus 2 up here. And then plus 1 times 3x, because I've multiplied by 100, equals 64, because it's 0.64. Don't write 64 and then get 6,400. Oh, that would be awful. You could do that by changing everything to pennies, but oh, that would be, I don't like that. You could distribute and then multiply by 100 and get the same thing, but there's more room for error. Now I'm just going to do my multi-step equation. I'm going to distribute and add like terms. So 10x plus 5x plus 10 plus 3x equals 64. When I add my like terms, I get 18x plus 10 equals 64. Subtract from both sides. And when I finally solve it, it's x equals 3. I don't know if you can see it down there. Now notice what I did. 3, you go back to what does x stand for? X doesn't stand for the value of dimes. X stands for the number of dimes. See? What was the question? What's the number of each coin? Well, if x is the number of dimes, x equals 3, so 3 dimes. And it's sufficient just to write it right here. You don't have to show me the math. If it's right here, it's very explanatory. Then I say, well, x is 3, so 3 plus 2 is 5 nickels. And 3x is 3 times, oh, I messed up, didn't I? It's not 15 pennies. What is it? If x is 3, it's 9 pennies. How do I check it? Well, 3 times 10 is 30. 5 times 5 is 25. Plus 9 cents is 64. So I always double check it. You make sure you answer the question. Did the question say what's the value of each coin? Or did the question say what's the number of each coin? Could be either one. You have to read the question carefully. So that is, I think that's the last one. It is. The geometry and the coin problem and the money problem. Whoops. Noise. The money problem are one of the most difficult problems, especially coins or dollars. And the one thing you just have to remember with that, the most challenging thing, is to remember that the equation has to be consistent. Either you're talking about value equals a total value where everything's expressed in money, or a number of coins, a number of dollars, a number equals the total number of the coins or the total number of dollars. That's the most difficult thing. You can't have them mixed up. It's kind of like you can't have inches and feet all mixed up. That's geometry. Something will be expressed in inches and something will be expressed in feet. And once you write your equation, you have to convert one or the other. Either that sometimes you write the inches as fractions to represent how many inches that represents out of a foot. And sometimes you convert the feet to inches. But it's the same type of thing, that in the equation, the units have to be consistent for it to work correctly. I want you to write down 2 things that you learned and 1 question, and I will see you tomorrow in class. And we will start this steady work, and you will be able to do this on word problems. So come with a positive frame of mind, and you're going to do great. I'll see you tomorrow.